Okay, standard enthalpy change of solution. Standard enthalpy change of solution. Okay, so this comes into the same topic as lattice enthalpy. But the last video was too long, so I've made it into a short, separated it. This is in the same topic as lattice enthalpy, okay? Again, there's lots of definitions for this. For the first, the definition of solution. Okay, so the standard enthalpy change of solution, okay, is the enthalpy change, we've got a lot of definitions to learn, is the enthalpy change when 1 mole of a solute dissolves in a solvent, under standard conditions. That solvent is normally water, under standard conditions. Okay, and it's normally water, all right? So let's say if we take 1 mole of sodium chloride, for example, and we'd be really sneaky, the solvent we just put as AQ, the water like that, AQ, and then what happens is the ions, you get the hydrated, you get the aqueous ions from the salt. Okay, that's the equation. That's the equation to represent the solution, enthalpy change of solution of sodium chloride. Now there's actually two things happening here in this overall equation. There are two things happening, okay? The first thing that happens is you need to break down the lattice. Break down the lattice is the first thing that happens, okay? So if you take the sodium chloride lattice, solid, that says solid, and you break it down into gaseous ions. Now do you recognize this, this equation here? Okay, this equation is the opposite of lattice enthalpy. Opposite of lattice enthalpy. Okay, you're breaking down the lattice, yeah? This equation here will always have, this step here will always be endothermic because you're breaking down a lattice. Okay, the second step in solution is once you broke down the lattice, you need to hydration of the gaseous ions. Okay, now this sounds complicated, but all it means is you take the gaseous ions and you surround them with water. Okay, so you get the aqueous ions. You do this for both of them. Now this just means that if you've got an ion, so you've got, like, for example, your sodium ion, okay, in water, it gets surrounded with water molecules. Yeah, but it'll be the negative end of the water molecules, and it gets surrounded with water molecules, yeah? And then the Cl minus ion will get surrounded with water molecules, but it'll be the positive end of the water molecules. And that's all that's happening in this step, yeah? The ions are being surrounded with water molecules. Now what will this hydration, will it be, and we put hyd for hydration, all right? Will it be positive or negative in value? Okay, so it will be negative because you are forming an attraction, so it'll be negative. What will the magnitude, what will the size be of these? This is breaking a bond, a strong ionic bond. This is forming an attraction, just an attraction, yeah? This will be a smaller number than this in size, yeah? Because this is just about forming an attraction, whereas this is about breaking a bond. Okay, right, so next. It has all the same kind of ideas in terms of the size of the ions, the same as lattice enthalpy. The charge on the ions, the size of the ions, affect the values. Okay, yeah, so for example, as the size of the ion increases, okay, what would happen to the hydration value? So this hydration value will become less exothermic, okay, less energy is released because the ion is larger, the attraction is not as good, yeah. Okay, as the charge on the ion increases, what happens to the hydration energy now when the charge increases? So the hydration will becomes more exothermic. So the more highly charged, the stronger, the better the attraction. Okay, and it's all to do with the attraction between the water molecules and the ions. Okay, so basically solution, very basically solution, enthalpy change of solution is the opposite, negative, the opposite of lattice enthalpy, the opposite, so change the sign, and hydration energy. Okay, that's basically what it is, the two hydration energies. Now you need to be able to draw a cycle to work this out, okay? So you're going to use sodium chloride as an example, the cycle. Right, so let me show you, this is a mini enthalpy cycle. Okay, so we're going to do this for sodium, so this is to work out, so the job here is we're going to calculate the lattice enthalpy of sodium chloride, but we're going to use enthalpy change of solution, and we're going to use hydration in order to do this. Okay, well that's the job. All right, so what I'm going to do is I'm going to show lattice enthalpy. So I'm going to draw it like a bit way down here. So I'm going to go do sodium chloride. So we're going to form 1 mole of an ionic compound. We're going to form it from its ions in the gaseous state, and that is lattice enthalpy. And that's what we're trying to find. Okay? Right. So we're going to take it in stages. So the first step we're going to do is we're going to hydrate the gaseous ions, okay? All right, so I'm not have much room here to write, I'm sorry. We're going to hydrate sodium first. We're going to go from Na plus gas to Na plus aqueous, hydration of sodium ions. We're going to keep the chloride gas as it is. We're just going to do the hydration of the sodium ions, all right? And that value is, I've got an actual value for it, is minus 406 kilojoules per mole. Okay, to do that, right? Then we're going to do the hydration. I've written this quite small, I'm sorry. The hydration of the chloride ions. So sodium ions, aqueous, and now chloride ions, aqueous. And that's the hydration of the chloride ions. And that value is minus 378 kilojoules per mole. Okay, and then to close this cycle up, if you go from the bottom to the top here, so we go from here, from sodium chloride solid to Na plus aqueous, Cl minus aqueous, that is enthalpy change of solution. And that value is plus 4 kilojoules per mole. Okay, so they give you all of these values, and then they ask you to work out lattice enthalpy, all right? So we go, okay, fair enough, right, so lattice enthalpy equals, so this is my start, this is my end, okay? So that is the same as going all the way around, like that, yeah? That is the same as going all the way around. So I'm going to go down here, the arrow's going in the right direction, so I just keep the value. The arrow's going in the right direction, just keep the value. And then I go down here, arrow's going in the right direction, so I just keep the value. But this one is going in the wrong direction, so I need to change the sign, and then that will give me my answer, which actually Do I know what the answer is? Okay, if you work that out, it is minus 788 kilojoules per mole. Okay, now it doesn't matter. Some textbooks, some exam questions, they write it the other way around. Okay, they write lattice enthalpy on this side, and then they go down like that. Okay, it doesn't matter which side you write the lattice enthalpy on. It doesn't matter. It's a cycle. As long as everything is there, it doesn't matter. Okay, the final part for this is if they ask you to, how do you calculate solution? Okay, how do you calculate enthalpy change of solution? So the final bit is, they'll say to you, experimentally, right, through experiment, how do you work out enthalpy change of solution? Okay, so what you do is you take a polystyrene cup. Okay, you take a certain amount of water, whatever that is. Maybe I take 100 grams of water. Yeah, you take the initial temperature, you put the thermometer in there, you take the initial temperature, whatever that is, then you add the solid, then you add your solid, and a certain amount of grams, whatever, let's say 5 grams of solid, whatever solid, you add the solid, yeah, and then you stir it, and you measure the final temperature. No, not the final temperature, that's not really quite correct. It's the maximum temperature or the minimum temperature, because it could be minimum. Okay, so it's whatever the highest temperature or the lowest, because it could be exothermic or endothermic. Okay, then you use the equation Q equals mc delta T, okay, which is just the energy change. The mass is the mass of the water and the mass of the solid, okay, because that is the mass of the solution. Okay, the mass of the solution times by the specific heat capacity, which is probably 4.81, something like that, times the temperature change. Yeah, then that comes out in joules. Then you've got to divide by 1,000 to make it in kilojoules. Then you've got to divide it by the moles, because you work out the moles of solid, and then that will give you your answer in kilojoules per mole. Okay, so you do mc delta T, that's the mass of solution, specific heat capacity, temperature change. Divide by 1,000 to make it into kilojoules. Divided by moles of solid to make it in kilojoules per mole. If the temperature went up, it needs to be minus. Temperature increase, it's minus. Okay, so don't forget that. So if the temperature increase, that's how you, through experiment, how you can work out the enthalpy change of solution.